Once upon a time, long, long ago, in a land of Modalys magic, at the beginning of this century, there was a secret manuscript written down, an ancient roll, if you so wish, full of mysteries and magic. And that one is not on this website, because it's called Finite Elements. No, it's not here. It is actually in your Modalys folder, wherever you might have installed it. It's in the help folder inside there, and it's called finiteelements.pdf. And maybe some of you already have heard of it, and for those who don't, it means that we can make 3D models in Modalys and play them. And what sounds juicier, honestly, than to be able to make your own 3D shapes, which you can then have any material you wish and play them virtually. Who is to say that you can't make a giant gong that has 20 meters diameter and is made out of pure gold or platinum? So here we go. We are gonna make a 3D shape today. I decided to go for a very ancient but very simple form. It's the bowl, and you can go from there. It takes a little bit of trying and getting used to it, because it's a mesh system. You can see that there is always the word mesh here listed, and that means that you can't really do complex 3D shapes like with dents and stuff like that, but you can pretty much do some very nice things. So that's what we're going to do today. So let's start. And this is actually, these 3D objects are actually the reason why I always wrote new and in package mlis in the header, because I have had with these some crashes when I didn't write that, or some bugging in the console. Okay, and now let's continue. So let's make our bowl. Make bowl. So to make a bowl, we actually need to orientate ourselves a little bit. We need to construct that 3D form. How do we do that? We actually start, in this case, with a single point. So I'm gonna set Q, so you can see it's a little bit older. There's still written define my mesh. If you try that, it's not gonna work. But it's a set Q, my mesh, and no, my bowl. I want to call it my bowl, and it's make mesh single point vector 0.100. That's what they have. You can also put 100. What I found out that it evaluates without any problem if you put in 000, but it just doesn't do anything. So it doesn't open the separate medit software, which gives you a visualization of your object. So that's that. So we have our point, but now we want to go further. So we go to duplicate rotation. So what I want to do here, they do a duplicate. In this example, you can see what it does. So it does this kind of rotation shape around a certain point, right? And we have to orientate ourselves somehow. So if I understood right, you can scroll through a bit the document and you will find the same, is that I found this picture. That was the only one I found where I could recognize that there was written X, Y, and Z going up. So I wrote that down in one of these famous sketches by me, and to keep myself barely sane while doing that, and go back to duplicate rotation. So what happens in duplicate rotation? I actually do, so here they also have this make mesh single point vector, blah. And then they do the duplicate rotation starting from the point my bowl, so from the mesh my bowl, and then what happens is that you give the number of extrusions, so here it's 5, and at the very end the angle every time, so 5 times 30 degrees. So if I say I want 90 degrees, I would have 9 times 10 degrees, for example, right? And the vector is in between these two. There. I would need 2 brackets here to fill. Then there are 2 vectors I have to give in. So there is the rotation axis, vector. I'm just going to put 0, 0, 0 first, but vector. So the rotation axis, if we think of it that we have a point here and we want to rotate it, right? In that case, we would like to rotate it around the y-axis. So from x, it would rotate up the y. So it would be the second number, that would be 1. And we can view the result as well. And there you can find it here in the documentation. There is a view mesh. So I can write here view mesh my bowl. There we go. So when I evaluate now, there is this little software which appears and it looks like 90 degrees. If I click Shift G, I can see it does it as I wish. Goes up 90 degrees. You can Shift P gives you the number of points. For some reason it starts here. I'm never 100% sure, but I think I have kind of figured it out. And what I write as a third argument in duplication rotation is the origin of the rotation. What I think happens is that this single point, wherever it might be, becomes the 0, 0. So it starts from there. If you write in 0, 0, 0, it starts from there. That's how I understood it, but I'm not 100% sold on that. But until now, it seems to work. Now the third thing we want to do, we actually want to rotate this around so it becomes a bowl, right? So this one that it would rotate like 360 degrees and so I can maybe zoom out. So it would rotate all the way around and come back here, and then we would have our bowl, right? So we need a second rotation. So we are again gonna go do a duplicate rotation, my bowl. And this time we are gonna do 36 times 10 degrees, right? And the vector, the first one, is gonna be around the z-axis. So 0, 0, 1. 0, 0, 1, right? And here in my book, that's still 0, 0, 0. We are not doing anything strange here, but let's see. So I evaluate again, and we have our bowl. Works. So that's the bowl we would like to play. But usually a bowl is not just a form, it has a kind of thickness to it. Although you can also specify that in the parameters of the finite element as well. I haven't played around with that enough to completely know my way around, but usually I make something that's called homotety. What a word, homothety. Duplicate homothety. Or homothety, maybe? Anyway, I had to look this up. I'm not a mathematician. What it basically does, it scales the whole object a little bit down or a little bit up, and then makes and connects that to the original object, and therefore makes it kind of thick. Right? What does that mean? So we're going to put that in here. Oops. What happened? There. Okay. So duplicate homothety, maybe, my bowl. And so they want the repetition. In this case, I want only one thickness. So I'm going to do 1. The vector there's only one possibility. It's in Z, so it's outward. So 0, 0, 1. No, in the height, I mean. Upwards, I mean. Sorry. There's only like, it can scale. Take this whole object and scale it a little bit upwards, but a little bit smaller or a little bit bigger downwards. And then we just need the scale. So 1.1 would be small, like just a little bit. If I evaluate now, you're going to see what I mean. So this is still pretty thick, right? You can also press C to have it in color, and you can press A so it turns around. It is all chic and cool, and we can feel like geniuses doing that. And so usually I even do it thinner, is 1.01, and there. Yeah. So here we go. We have our bowl. And these little squares are all the little points that we can beat it on or bow it on or whatever we wish. So that's very, very, very cool to have. And you can go crazy. You can really go crazy. You can change out parameters. So sometimes I just play around and I do something like that and that and do something like that and evaluate, and I get crazy forms like that, which can also be cool to have, right? But let's stay traditional in the sense of the old manuscript today. Oops, that's also nice. 0. Okay, so back to the bowl. Okay, so we have our 3D object. So how do we calculate that object? So for that we have compute modes. And to compute the modes, we first have to make a finite element out of it. So we have first to go to finite element here, right? Okay. So we make object finite element, and usually we want to give the object a name. So set q my final bowl, right? Make object finite element, and we have all kinds of parameters for different materials, but also some extra ones. So the mesh we are using is my bowl. I would put this down as well. My bowl. Then we can block a submesh, and that we are going to do that, but I'm going to first finish with the rest here. So we have the modes. The higher the modes, the more overtones you have. So let's put in 300. The density 7800 here. The young to E11, not the Poisson 0.3, And the frequency loss, let's put it a little bit longer, 0.5, and the constant loss as well to have more fun, 0.5. There. You cannot tune a finite element, and you have to compute its modes before you can play around. So we still have to compute the modes. That's what you do here, compute modes. There. So compute modes, and it's called my final bowl. So if I do that, it takes a little bit of time, see here, and it loads it. And that's why you can make these 3D objects in Modalisp and also in OpenMusic, but not in Max. To use the Max, you have to make a file. So to render out kind of a file of the 3D object, and it gives you out the .modal file, which you can then load in Max. But we're gonna get to that later. For now, we are just gonna do this inside here and then in OpenMusic. Okay, so next, sometimes if we beat or play a bowl and we don't block it somewhere, so we don't hold it, it doesn't have a ground where it's held, then it happens to me that it's not played anymore. The bowl seems to float away into the virtual abyss of the Modalys universe, never to be seen again, ever, and heard especially. So what I have gotten used to is to do this. So we need a submesh of that object, which we are gonna block, which we are gonna hold, right? So I'm gonna call it hold, so set q hold, and make mesh restricted quadrilateral. And now we need a vector of 4 numbers, what we want to block. Not only that, they forget a little thing here, but they don't forget it here. It needs the name of the mesh that we are taking the submesh from. So I need to write in here, restricted quadrilateral. He's like, yeah, where? So it's on my bowl. And how do we find what we want to block? So in medit, you can zoom in, and you can with shift click on one of these meshes, for example, and it should report it to you here. The quad is 296, 10, 10, 297. So that's our vector. Let's put that in. 296, 10, 10, 297. There we go. Let's compute error Modalys, please read console. And there's another little problem. So you see here, we wrote that restricted quadrilateral, but here it's called restrict without the ed at the end, quadrilateral. So that might be the fault. So if I put it now, it works. Okay. So now we can go here and place in block hold, so that it blocks and holds that mesh here, right? Okay, so that's for this one. We have our 3D object. There are some nice things that you can also view. So if I copy that and put it all the way down here, you can not only view the object, you can also view its modes. What do I mean by that? I mean that you can see which mode, so of the modes that the overtones, right? The modes out of these 300, you can see which ones makes the object vibrate. For that, you just need to write mode, my bowl, and you need to write which mode do you want to see. So the first mode would just be it whipping, like the whole object just moving forth and back. Then you need the frames, so let's say 25 frames per second. And how often should we repeat that? Let's take 10, that should be enough. So let's see. Oh, he didn't like that. Invalid argument. Oh, my final bowl. Probably. Yeah, here. You see, now you saw the first overtone. And the bigger ones are interesting to see. So let's say overtone number 23. So these are the different ones, how they kind of react, and so on. So you can have fun with that one. But I'm gonna go back to mesh. My final bowl, or my bowl. Yeah, it matters now. I'm gonna put my bowl, and there we go. Okay, because I need that, because in the other view of the modes, I can't select different parts of the 3D object, and I want to be able to do that. So now we are gonna play that wonderful object. We want to hear how it sounds. And we're gonna do that because it sounds nicest. It's my favorite connection with the bow. Okay, so we are gonna make the bow. And set Q my bow. We have been through this. Make object B to mass. There. There we go. Okay. We have now the axes to make. Make axes. And here we can go pretty simple. We can do the first two axes for the B to mass, right? So actually the 4 axes. So we have set Q my bow vertical. So we did vertical and horizontal. We need to keep in mind what is what, right? We remember all of that. Vertical touching, touch, vertical touch, and that will be make axis on my bow. It's gonna be the constant 1 and trans 0. There. We're gonna go do the same thing 3 times. So here, this is H touch, and it's trans 1. Here now we move over to V move and H move. Bow H move. Make object, and here both are 0, and 1 is trans 0 and 1 is trans 1. There we go. Now let's decide where we are gonna bow this nice bowl. So we can bow it here, for example, there. So I'm gonna shift click here, and look, what's that? Okay, and I can even, if I turn on the color, it's easier to see. I can even zoom in and see which points these are. So there's 412. That's a good point to bow. So set Q my bow, my bowl, yeah, my bowl touch, and this is make axis my bow, my final bowl, and it's constant 412 and normal. And we need it twice for vertical and horizontal, which is why I'm going to write the V and the H in here now, and evaluate and see that he's not happy. Oh, of course, I forgot the bracket at the end. So now it works. Okay. Next, we are going to bow. So make the connections. So we need a bow connection. Make connection bow. And just for us to remember this, we're going to go back one more time here to the bow and remind us what that meant. So we have the bow axis from the bow itself, so the vertical, so my bow V touch and my bow H touch, which are at 0.1. Let's position them as always, or 0.1, doesn't matter too much, 0.1. And then it's connected to my bowl V touch and my bowl H touch. And this is at 0. Now we have the 4-dimensional controller, which we are going to write down with 2, 10, 5, 4. And there we go. We have our bow connection. And what I just noticed is that we didn't yet set our listeners. We are actually going to do one listener. So set Q my bowl out, or listener. It's still the same, make axis on my final bowl constant. We are still going to figure that out. So here, we're going to go back here and look, okay, we have 412. Where do we want to hear the sound? Maybe here. So what point is that? Did it show it to me? Yeah, here, 28 maybe. Yeah, 28 is good. So 28, normal. That's how it's connected now. Now we are going to make the connections to move the bow. We are again going to use position for the vertical and speed for the horizontal movement. So make connection position. We're going to move the my bow V move. And it's gonna make controller envelope 1. We know all that by now, so we are gonna do a little bowing action. We are gonna start at 0.1, and then it's gonna slowly push down on this. So at 0.5, it's gonna be at minus 0.1, and at 2.2 seconds, it's gonna go still strong minus 0.05, maybe a little bit softer, and then at seconds 4, it's gonna be at 0.1 again, so above the object itself. Now we are gonna make the connection speed on my bow H move, which is gonna also take an envelope, make controller envelope 1. So at time 0, it's going to be at speed 1 meter per second. At time, let's say 2, it's going to be at speed 4. And at time 4, it's going to be back to speed 1. So a very classical, and you can play around with that later. Now we just need to output and synthesize. So we know all that by now. Make point output my bowl listener. You can also make several ones and kind of mix them together. And now run it for, let's say, 7 seconds maybe, so we get everything. And I already now apologize for a little bit of distortion, but it will be cool in Max. Okay, so let's evaluate. My final is unbound. Where did I write my final? Ah, there, my final bowl. I'm sorry. That was anticlimactic. Okay, now for the real one. Okay, that was more like something dropping on the bow, so maybe it's not fast enough. So we can go up to speed 10 maybe, and maybe it's pushing too much down. Let's see what happens now. Very, very, very nice sound. But it's still 20 maybe. Ah, that's more like it. So maybe we have to start much faster. So at 15, speed 15, and that's more like it. Nice, huh? And now it cuts off, but we are gonna hear obviously the best of that later in Max. Okay, so for now, let's move over to OpenMusic. So in OpenMusic, we can pretty much do the same stuff. We can make a new patch. But there is a secret object here as well. So bowl, bow. No, bowed, bowl. That's a nice name for one of my, I have to admit, it's gonna be one of my last tutorials. Maybe I'm gonna do one more, but then I think I've pretty much covered most of the stuff I think I can cover for now, but you're welcome to suggest any ideas. So we are here. How do we make a 3D object? So you have, if you load the library of Modalys, you will see that you have also with the right-click menu all the objects, controllers, and you have something for mesh. So you have the single point, which we need. Also read from file if you save that 3D object as a file and so on, and want to read it. So especially as soon as you make bigger and more complex 3D objects, with more modes and more meshes and everything is fine, then it can take a very, very long time to render all the modes. And then you want to actually save it as a modal file and have another patch or script that loads that file to play it, because else you're going to spend a lot of time waiting. And here for the functions, we also have in Modalys for the mesh some, so the duplicate we're going to use, mview we're also going to use. Okay, we can close that mview. So let's start. We need a single point. Mlis, a single point. And that's not what I expected. So there are some differences. So I'm gonna go for 100% sure and go here, and I can see, it's mesh single point. Okay. And that looks more like what I was expecting. So we have the single point, and we need the vector. What I have seen in the example patches is an mlis vector. And it appears. And with Alt and cursor, I can even make an input. So I need 3, it's 3 numbers. So 1, 0, and 0. What I don't get is that it seems to be hidden away. It's not to be found here in the Modalys library. Not at all. So who knows where it might be? Is it here? Mesh? No. Is it here? No. I can't find it. So it's a secret object. Who knows? Anyway. Now next we are gonna duplicate. So I'm gonna take to here, to Modalys duplicate. That's the function. And that function takes actually over, if you remember, maybe if you saw it, a duplicate has several, it has homotety, reflection, and rotation, and translation. So as functions, so we can use all of those. Even helix, there's something that's called in reflection. So we use rotation here. Then the object which comes in is here. But then I need inputs, depending what I'm doing. So in this case, we had 4 things we wrote into for the rotation. So we had 9 times at the end 10 degrees, right? And we had 2 vectors. So I'm just going to duplicate those, put them in here, in this one and this one, the 4th and the 5th one. And I have to write in the right numbers. So here it would be 0, 0, 0, and here we turned around the y-axis. I mean, so it's the 1 is here, and here is a 0. There. Yeah, and we even have the mview. So I can use that, evaluate it here, and also open everything. So see the same thing, right? Okay, so let's continue. We need another duplicate. It's also rotation, so I'm gonna just copy the whole thing, copy paste the whole thing. So this is what we're gonna duplicate. It's still a rotation. We can basically now attach this here. And the rotation is now 36 times 10, so 360 degrees. And here it's around the z-axis. So here it's 0, 0, 1. And here it's 0, 0, 0. So that should lead to our ball. We have it back. The last we need to do is again duplicate, but now we need to make the homotety, it's called. So here it's homotety. And Homotopy needs only 3 arguments, so we can, with Alt and go back, erase some. So we need 3. We only need 3 numbers, so 1. Do it once, 0.01, and the vector was 0, 0, 1. Yeah, that's right. And now we have the thickness as well. Good. So we have our 3D object, and the rest is simple to do. From now, you should know your way around. It's easy peasy. We actually just need the finite element. So the classes, we go to mesh. Oh, we need the restrict quadrilateral too. Okay, let's do that. I would have almost forgot. So here is what we are using. So we go in here, that's original. And we restrict this vector. So we need a vector again, but this time with 4 numbers. And these are 296. If you remember here, we selected one here, right? We selected the bottom 10. If you don't remember, you can always go back. And here we have 297. That's our blocked one, and now we can go to the objects, right? The object is a finite element here. Here we go. So what does it need? The tuning parameter, as far as I'm concerned, does not work on these, but who knows? Maybe I'm wrong. Maybe there is something you can do after all. Then there is the mesh. So the mesh is this whole thing. Oops. Okay. Mesh. Then we have all this density, thickness, Young, Poisson, frequency loss, where I'm going to write in 0.5, and here, oops, 0.5. And because I'm in a good mood, I like these 3D objects, I'm gonna do the bowl out of gold. Object properties. Where is my gold? 19,300. That sounds good. Oops. Where am I? Here. So the density is 19,300. Then from gold 7.9 E10 and 0.43. So the Young is 7.9 E10 and Poisson is 0.43. There we go. We have a golden bowl. I like that. Okay, and the rest is now history. So now we are gonna make our bow. So Modalys B to mass. We need our axes for the bow, so Modalys axis. And we need 1, 2, 3, 4. So over here, 5, 6. And 7 for the listener. Okay. So the object, this object goes here, here, and here. Then this object goes here, 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 and here. There. Okay. if we take these two as being bowed, this one as, let's say, being listened to, these two as being touched, right? Okay, then we can kind of configure them in the right way. So this is my listener. So what we wrote was 28, right? And we said it was normal. Here we wrote in it's being bowed at 412, the point 412 here as well. And both of these are normal as well. On this one here, we have these four. So the one we are moving are these two. So they are both at 0 and 0. One is at trans 1 and one is at trans 0. So vertical and horizontal. Here the same thing, vertical trans 0, horizontal trans 1, and this is both at 1. Now we need the bow connection, mlis bow, which is going to combine all that together in a good way. So we combine first the bow. So bow is vertical, horizontal, the position 0.01, then the vertical and the horizontal. This doesn't matter too much, both are normal at the same point. And we have the string vertical position, which is at 0, and the controller for the Rosen 2, 10, 5, 4, which is the brackets. There we go. Whoops. Oh, I did that. Okay. So I'm just going to do that. Okay. Here we have our mlis point output, which takes this axis. And here we need our movement. So as always, we go to mlis position connection for the vertical and the mlis speed connection for the horizontal. We need again mlis envelope twice, here and here. Oops, there. And we again need the BPF twice. One there, one there. Okay, this goes in here, this goes in here. Value M. Now let's write in our things. So for the position connection, we have 0, 0.5, 2, 4. Okay, so 0, I should actually start at 0, 1, it's cleaner, minus 0.001, minus 0.005, and 0.01, close the bracket, there, and this should be at 3. So here we have our position vertically, and now we need our speed, which is very simple. We tried it out, we needed bigger speed, so 0, 2, 4 are the times, and 15, 20, 15 are these, and we're going to put 2 here. Okay, there we go. Okay, now just synthesize. So mlis synthesize. It's all kind of now squashed down here. I'm sorry if it doesn't look too pretty, but I think we are gonna survive that one. Oops, come on, there. And we still need mlis new and mlis run. And now let's start. So the new comes in here, then all the other jazz. So this, all the way from over there. This, and if you want to, if you're squashed like that, you can also make sub patches. Or give colors to the cables and everything. I'm just now thinking more functional and also time-wise. These tutorials are long, but I hope it's okay for you. We said it would run for let's say 8 seconds, and now we can synthesize. There we go. We have it. Haha, that's great. We should have it much longer. Let's say 15 seconds. Well, that's the gold. Gold sounds cool. I like it. So this is going to take a little while. Oh, it stays sounding. Interesting. Oh, I think it still kind of touches because I wrote 0.01 instead of 0.1 in this here. So if I go back to 0.1, it will probably end earlier, I guess. Yeah, now it's... But it has this sharpness, so you can play around with pushing it into it more, having bigger speed, smaller speed, and so on. It's really nice. Come on, it's really nice. I like that function. These 3D objects just can be great. Imagine having a 20-meter diameter gong out of pure gold. It's great. Who wouldn't like to have that? The thing is, what you can do, just putting it out there, is you can have this bowl. You can make it bigger or smaller. In that case, you should define a variable with which you can scale just the whole thing, because that's kind of in meters, right? And if you put in a variable, you can scale the whole thing up and down. You can also adhere other objects, so glue other objects to these objects, right? And what I forgot here, actually, is you can block that one. It works here because I'm only playing it once, but it should be blocked. So don't forget here, if you play it several times, else the element can sometimes float away, as I already mentioned. Yeah, so that's that. And now over to my dear friends in Max. Well, I have some mixed news, let's say. And that's why I'm not gonna go through it one-on-one, because I just can't find out why it sometimes works and why it doesn't, and even the same patch that sometimes works and sometimes doesn't. But what I can tell you is that sometimes it works. And so I'm gonna show you a, I hope, working patch now. You never know. In these 3D objects, in Max, Modalys seems to be a very moody diva that needs to be treated nice, and even then, you never know. She might turn on you any given time. So there is an extra line, so you can't make 3D objects in Max. You have to make them in OpenMusic or in Modalisp, as I have my Modalys script here. And then you need to save and export the file of the mesh of the finite element with this line. So you basically need a save object. There is documentation about that on the Modalys website. You put in the name of your object, so my final bowl. And there is, I found that in a video, I screenshot it, make path name in directory of source file. I have not found that in any documentation. I would be very, very thankful if somebody out there could put out a list of these kinds of command lines, because they are super practical to have. And then you put in the name. So that's my name, and it has to be .modal. So it's a modal file you are exporting. So usually you would only evaluate that part of the script with Command E. And it should work. However, and it makes this file here, my bowl modal, the higher the modes you make, the more meshes and points it has, the more time it's going to take, obviously. But that's the file you need to load in Max. Sometimes when evaluating just this area, I have had some weird bug, some weird complaint from Modalys that was saying that something went wrong and it can't do that. And that was simply solved by just evaluating the whole script. So I don't know exactly what's going on there. But let's move over to Max. And because it's not reliable, I prepared a patch that for some reason seems to work now. And that's the patch. So I'm going to go through it. I have a live drop object and basically trigger different nodes where I want to get to touch or to bow the bowl, right? The initial inputs and the initial out positions. I am not completely sure why. So also here, I kind of stole, well, not stole, I got inspired by one video I saw. I'm not quite sure why there are two numbers of nodes being necessary here, and just one for each initial position in. But that's how it looked in the example I saw. There is unfortunately no documentation about the mlys read from file, which is basically the object you need to load the 3D object. You then put the object, you just drag it into the drop file. It sends out the conform path max boot, so it puts it in a kind of form where you prepend the message file name, which then mlys read from file can understand. And the rest, as you can see, is pretty close to what we have done until now. The only difference is that for the bow I put two positions. So I'm bowing kind of in that way, and this is the vertical position. And I'm bowing with signals here. So I have an mlys signal in front of everyone and 2 point inputs. And at the end I need quite a bit of amplification. So here we go. I turn on the sound and you just take your modal object and you put it in here. It loads and then you can play wonderful sounds. I would advise you to, I haven't done it here yet, but I would advise you, especially with big objects, to put on a low cut filter. It can be very dangerous, I think, for your loudspeakers, for the bass. Sometimes these objects have very deep frequencies, so maybe you should cut them away or at least narrow them down. Yeah, but that's basically our patch, which seems to work now. Just 5 minutes ago it wasn't working. Well, 5 minutes, 10, 15 minutes ago. And the strange thing is that the console then was complaining that the object had 650 nodes. All the numbers I have here are under 615 or 12, whatever it said, nodes, 650. And that it couldn't apply the type normal access to these nodes, which didn't make any sense, because now it works. So if anybody out there has inside information, once again, I would be very, very thankful to know more, because it's really quite magical to do. And I really enjoy the sound possibilities through this physical modeling gem of the software. Well, let's say diamond in a raw. Okay, so that's it for this tutorial. I'm maybe gonna do a small one more, but I think then for now I will be done. You're of course welcome to suggest anything I should still do or try, and I will see if I get to it. So all the best, and see you on the next one.